Hey everyone. So, happy new year. We're continuing on with factoring. So, we're just going to take it to kind of the next level. So, today we're going to focus on something called factor by grouping. So, here are two review problems. So, do these. So, number one, notice that we have an x to the sixth and then an x to the third. So, the fact that the middle term is half the leading term, right? That's a 3 and that's a 6. That tells me that this is an MC chart. So we're multiplying to negative 56 and combining to negative 1. That's 7 and 8. The 8 is negative to give us negative 1. So I get x cubed and x cubed plus 7 minus 8. But then if I look here, I can do more. X to the third minus 8 is the difference of two perfect cubes. So that is our x minus a, right? X squared plus ax plus a squared. So we're going to use that formula. The x to the third plus 7 we can't do anything with because 7 is not a perfect cube. There is a way to do it, but it would be really ugly and terrifying. So the cubed root of 8 is 2, so it's x minus 2. And then we get x squared plus 2x plus 4. All right, number 2. So that is a binomial subtraction, and everything's a perfect square. So I have 4x squared, right? 4x squared times 4x squared is 16x to the fourth. And then 9y squared. Now this one, that second one is factorable. 2x, 3y. One's a plus, one's a minus. And then we can leave this first one alone. If you want to factor it, you can. There is a way to factor that using imaginary numbers. So it's the same. It's just like the other one. It's 2x plus 3y. 3iy. We just have to throw an I in there. That's all. 3iy and then 2x minus 3iy. And then the other one stays the same. So if you want to do that, you can, but you don't have to. Unless I specifically tell you to in directions. Okay. Factor by grouping is a method of factoring more than 3 terms using the GCF twice. Typically, the steps involve a GCF that is a monomial followed by a GCF that is a binomial. So it's factoring typically 4 terms. I usually do this using 4 terms. There are some special cases that we're going to go over, but they're really not as common. So the first type is really what we're going to be focused on. So notice we have 4 terms here. So whenever I see 4 terms, I automatically try factor by grouping. So what I'm going to do is I'm going to look at the first 2, and I'm going to try to factor out a GCF. The GCF there is x. So x plus 6. And then I'm going to look at the second one, the second term, xy plus y. And what's the GCF there? Y, x plus 6. So now notice both of these have that x plus 6. So now imagine we're actually doing a GCF of this whole thing of x plus 6, right? And if we think of it as division, x plus 6 goes in, the GCF goes in the front. Those cancel out. We divided x plus y. So that is factor by grouping. We factor the first 2, factor the second 2, and then we're left with a binomial that's the same. So pause and try number 2 on your own. So my first 2, my GCF is x. And then for those, my GCF is 2m x minus 4. So then I have a GCF of x minus 4. Cancel out, x plus 2m. And that is the answer. Okay, so this is just the same thing. So I want you to pause and try these on your own. Alrighty, so I have a GCF here of x squared. So that's x squared times x minus 7. And then over here we have a 2, x minus 7. X minus 7 is in both of them, so I get x minus 7, and then x squared plus 2. Right. I'm pulling out that x minus 7, and I'm left with x squared plus 2. And then a lot of times we can factor again, x squared plus 2, but that does not factor unless you use imaginary and square roots. So that would be gross. Number 4, we have a GCF of x plus 3. Now here, notice these are both negative, so I'm going to do minus 5m. So minus 5m, and I'm left with x plus 3. And then notice x plus 3. So that's a GCF, and we're left with x minus 5m. Done. All right, same idea. Pause, try these on your own. All right, so my first two, GCF is x squared. Now, for the next one, pretty much whenever I'm doing these, if I see a negative there, I'm going to make my GCF negative. So I'm going to divide by negative 3. So negative 3x minus 6. If you just did 3, your sign would be off. So we got x minus 6 as my GCF, and then I'm left with x squared minus 3. Again, if you want to factor that, you could do x minus 6, x plus root 3, x minus root 3, but that's really not expected necessarily. But I like to bring it up just because I don't want you to think it's impossible. It is possible. It's just not something we typically will write our answer as. Okay, and then this one, k. So I got k plus 2. And then we got, let's see, minus 9p, k plus 2. So k plus 2 is our GCF. When those are pulled out, we're left with k minus 9p. That's it. Okay, so now I'm pretty sure these we're going to have multi-step. Yeah. So these we're going to end up having to factor again. So pause and try these on your own. All right, so my GCF here is x squared. My GCF here is minus 4. So x squared, 2x plus 5, minus 4, 2x plus 5. So we get 2x plus 5, and then x squared minus 4. Now in this case, you have to factor again. X squared minus 4 is the difference of two perfect squares. That's a dots. You have to factor that. So 2x plus 5, and then x plus 2, x minus 2. So if it is like easy factorable, it is required. If it's something weird like with the 3, you can, but you don't have to. But in this case, you have to factor this. Same with number 8. So if you didn't factor a second time in number 8, pause and do that right now. So we've got m squared, m plus 7. Now over here, my GCF is negative 1. Because this only works when the binomial is exactly the same. So we get m plus 7, m squared minus 1, and then again, just like before, m squared minus 1 is the difference of two perfect squares, m plus 1, m minus 1. That's it. Okay, so I want you to pause and try number 9. So if I automatically try GCF of x, and then this, is there a GCF there? No. A lot of kids will say, oh, well, it's dots. 3 plus y, 3 minus y. But that's not really helpful, right? We can't really do anything there, so this is not right. That's what I said. Okay, so with these are the ones that we don't do as many of. Take a look at this. Do you see it? We're going to group, but we're not going to group 2 and 2. We're going to group 3 and 1. So which 3 do you think go together? If we look at this first set, x squared plus 6x plus 9, how does that factor? That's an MC chart, right? Multiply, combine. And it's actually a perfect cube, binomial. It's x plus 3 times x plus 3, which is x plus 3 squared, and then I'm going to write that y squared at the back. But now notice, this is actually the difference of 2 perfect squares. Think of x plus 3 as like a squared minus b squared. So it factors x plus 3 times itself. So x plus 3 times x plus 3. And then we have our y squared y, so y and y. One's a plus, one's a minus. So these are a little weird, but they're doable, all right? So try number 10 now. So I'm going to factor my first 3. M squared minus 10m plus 25. That's our m minus 5 times m minus 5. So m minus 5 squared minus n squared. That's a difference of 2 perfect squares. M minus 5 times m minus 5 is m minus 5 squared. And then my n squared is plus n minus n. And that's it. Okay. Getting a little weirder. Now notice how many terms we have here. We've got 1, 2, 3, 4, 5, 6. 1, 2, and then the bottom one is still 4. All right, so take a look at this and think about what you can do. Look for things that feel like they go together. So these first 3, for instance, that is a perfect square binomial. That is x plus y times x plus y, which is x plus y squared. And then does anything else look like it goes together? If you look at this now, 6x plus 6y, we can factor out a 6 there, right? I'm going to take out the 6, and we're left with x plus y, and that minus 7. So now imagine, treat that binomial of x plus y squared as like one variable. So this is like a squared plus 6a minus 7. That is a just regular MC chart, right? What multiplies to negative 7 combines to 6. So when we factor this, what multiplies to negative 7 combines to 6, that's positive 7 and minus 1, right? But instead of a and a, what is being squared? X plus y, x plus y. Right? So that's pretty tricky. The first time I saw that, I was like, oh wow, I never thought to do it that way. Okay, so what makes these not as bad is when you're doing a bunch that are all similar. Now look at number 12. We're back to only 4 terms. So n to the 5th, n to the 4th. So what do we do? Whenever you have 4 terms, I always default try to factor the first 2, try to factor the second 2. Because when I looked at this, just now. I hadn't done this problem in a year. I was like, wait, how do I do this? And then it occurs to me, just let's go back to what we know. You should always default, just like always check for a GCF, right? We're checking for our GCF. So n to the fourth. N to the fourth, n minus 3m. And then over here, negative 16m to the fourth. Negative 16m to the fourth, n minus 3m. So we have n minus 3m, n to the fourth minus 16m to the fourth. But this is a dots. So now pause and do the dots part on your own. All right, so we got the n minus 3m. And this is going to be multiple times too. N squared. What times itself is 16m to the fourth plus 4m squared minus 4m squared. And then there is another factoring in here. This is another dots. You can do this one, right? You can throw the I in there if you want. You don't have to. This last one though, that is a regular dots. You have to factor that. So n squared plus 4m squared. And then we have our n plus 2m and minus 2m, and that is factored. All right, so this one, these are really similar to what we did earlier, but they're slightly harder. So I want you to pause and see if you can figure these out. So for number 3, the first time I saw these, what I tried to do was I said, oh, well, that's x plus y, x minus y. But that ends up not being helpful. And that's what makes these hard, because sometimes you can factor things, but it's not going to help you factor the entire thing. What you need to notice is this. Oops. Why is my pen not working? That is a perfect square binomial multiplied out. However, there's a minus in front. So we are going to factor out that minus. X squared minus y squared plus 12y plus 36. Now you have to do that. This is y plus 6 times y plus 6. So x squared minus y plus 6 squared. Now here's what makes this difficult, even more difficult. This is the difference of two perfect squares, right? X times x is x squared plus y plus 6 minus y plus 6. But you have to put either parentheses or you have to distribute, because you're subtracting this entire thing. So when I do this, usually I write it like this. And then x minus y minus 6. You have to distribute that negative to both the y and the 6, right? So now pause and do 14. It's just like 13. All right, so the first thing I'm going to do here is I'm going to factor out that negative. 16n squared minus m squared minus 10m plus 25. That's going to make this factorable nicely. So 16n squared minus m minus 5 squared. Now I have a dots. What times itself is 16n squared? 4n plus my m minus 5 minus m, and then I'm going to distribute to the 5 plus 5. And I am done. Okay, last one. Pause, see if you can figure this out. I do agree that these are tricky because they're very different, all of them. You kind of have to look for patterns. So for this one, what I did is I saw that and I said, oh, that's x plus 2y times x plus 2y. And then I noticed that's kind of nice because right here, the second one, if I factor out a 1, I get x plus 2y. So x plus 2y squared minus x plus 2y minus 12. So now that just turned in to an MC chart, right? This is my a squared minus a minus 12, right? A squared minus a minus 12 is a regular MC chart. What multiplies to negative 12 combines to negative 1. So we get a and a, right? But instead of an a, x plus 2y, x plus 2y. Multiplies to negative 12, combines to negative 1. 3 and 4, and our 4 is negative. Plus 3 minus 4. All right, last one. Do that one on your own. Same idea. So I'm going to do this a little faster. Ooh, this one's different. This is x plus 7 squared, right? X plus 7, x plus 7. But the next two, if we try to do an MC chart there, that's not going to work. However, if I factor out a negative 1, n squared plus 8nm plus 16m squared, that is a perfect square also. That's n plus 4m quantity squared. So now we have a dots. This right here is a dots. X plus 7 times x plus 7. And then n plus 4m minus n minus 4m. Make sure you distribute. And that is factor by grouping. We're going to spend another day on this because I know this is tricky.